Hello everyone, my name is Yana Harris. I'm a principal front-end engineer with over 13 years of experience. And today, I would like to go over one of the technical interview questions I was asked over the last 18 months. Throughout the years in my career, I had made it a point to make sure that I keep up my interview skills up to date and continuously practice. Interviewing with a new company doesn't always mean that you're going to take a new offer and change your job, but making sure that you know what your options are, you know what the market is offering, as well as keeping your interviewing skill up to date is extremely important in my opinion. So like everyone else, I'm sure I have some strength when it comes to interviewing, and I certainly have some weaknesses. Over the years in my career, I certainly spend the majority of the time writing UI components and web applications. This means I primarily work with frameworks and libraries like React, Svelte, or Lit Element, and I really don't get to write vanilla JavaScript that often on a daily basis. In fact, if I have to write vanilla JavaScript without TypeScript at my disposal, I often fumble and feel unsure because it's so different from my daily practice of writing code in an IDE that has autocomplete. Even without an assistant like a copilot, an IDE like VS Code usually provides some autocomplete functionality, which is extremely useful when you're relying on a well-known and established browser APIs. For example, if you're working with arrays, you will be able to see a list of available methods within an IDE while you're trying to manipulate an array. And I gotta be honest, I have really been relying on Copilot a lot lately, as well as ChatGPT or Claude 3.5, especially ever since I switched to working with Cursor AI instead of VS Code. A little funny tidbit about myself, I picked up React as well as TypeScript literally on the same day on the new job back in 2016. And for a few months there, I was trying really hard to figure out where does the React end and where does the TypeScript start. I never went through an education course. I simply learned my skills on the job. It sounds ridiculous today, but hey, this was my learning journey. So going back to the interviewing. Over the last 13 years, I made it a point to make sure I interview at least once every 18 months to keep my skills sharp. But even today, I am terrified of the technical part of each interview. I tend to notice that I really don't keep all the details of the interface and the syntax in my mind at all times. Partially because I can go and look it up online in documentation or ask Copilot to assist me in finding the right method. So with this in mind, I really want for us today to go back to the basics and talk about one of the fundamental concepts of JavaScript, which are prototypes and prototypical inheritance. So let's get started. One of the questions that I was asked in my interviews last year when I was on the market looking out for a new opportunity was to write a FlatMap method from scratch for an array object and extend it through a prototypical inheritance. We're going to do just that today, but before we get started, let's quickly talk about prototypes. So on Mozilla documentation, we can review what the object prototypes are, and it says prototypes are the mechanism by which JavaScript objects inherit features from one another. And that makes total sense to me. I have looked at this definition countless times. However, to be able to express this in a stressful environment of an interview, I have come to a realization that I need to have a metaphor associated with a prototype. And the best metaphor that I could come up with is a DNA. So imagine you have an object, and this object has its DNA. It has its features recorded in this DNA sequence. It has its methods recorded in this DNA sequence. If we're trying to create a brand new object, a baby object of sorts, this baby object can now inherit from the original object through the prototype. The prototype is the DNA. The DNA allows the baby object to take the features that it needs, take the methods that it needs, and override or discard anything that doesn't make sense for the baby object to inherit, and so on and so forth. So in my mind, an object prototype in JavaScript is like a DNA sequence that allows a new object to inherit features from the parent object via the prototype. So quickly, still on the same documentation, we have the parent object here that is called my object. It has a property of the city and the type of a string, and it has a method of greet, which you can call the way you would expect to call an object method. So as you can see over here, it says every object in JavaScript has a built-in property, which is called prototype. It's important to keep in mind that while the parent object will have a prototype, the baby object will also have its own prototype because baby object will grow and eventually will pass on its DNA to another set of baby objects. One thing that doesn't quite land into my metaphor is the fact that the prototype itself is an object and it has its own prototype, which is called a prototype chain. The way to think about this is the way you think about your own ancestry. I'm going to stick with the DNA metaphor for a second here. So you have a DNA that you have inherited from your parents. Let's talk about your mother. Your mother has a DNA that she has inherited from her parents and her mother. And we can keep going this way until we reach a mother that doesn't have any parent. If we go all the way back to Eve, Eve is not going to have a mother, and her prototype will essentially be null. Hopefully you're having as much fun with this as I am. Just a little trivia that each object has a property that actually points to the prototype, to its DNA sequence, and its name is _proto . However, the way you would access an object's prototype is via getPrototypeOf method. So a great example of typical inheritance is when you create a date object. Let's say you have a const that you call myDate, and you initiate a new date with it. And we can go ahead and reassign an object to myDate at the next line. So prototype of myDate is actually going to be date prototype, which means every time that you call a familiar method like getTime on your new date object, you're actually looking for those methods within the date.prototype. You did not create those methods on your brand new project. Those methods, in fact, are inherited from the date.prototype instead. So now we're getting closer to the exercise that we're going to do today. While creating a brand new method or recreating an existing method in JavaScript is a valid interview question, you shouldn't do that in a real life production project. And the reason for it is that you most likely are not the only engineer working on this project. A lot of other people who contribute to this project might be relying on a consistent and predictable prototypical inheritance while they're trying to manipulate the data. For example, for every date that is created in your application, every engineer is expecting to get a consistent result when they call a getTime method on their new date, because it gets inherited from the date.prototype. However, if you proceed by overriding this method with an obscure function, this one, for example, just logs a message in a console, you actually will globally override this method for everybody who's trying to access it throughout your application. And this is a very dangerous situation because it now creates an unpredictable result. So when you're trying to create a new baby object while inheriting from an existing object through its prototype, through its DNA, there are multiple ways to go about it. One is to use object.create. Again, going down through this documentation, we have a person prototype, which is going to be our parent here, and this parent has a method of greet. Now we are creating a baby object named Carl. Carl is going to inherit DNA from the person prototype via object.create. And we're going to pass the parent into the parentheses. Now, Carl can also greet because Carl had inherited this behavior from its parent object via the prototype inheritance or its DNA. Now, here's another example. In this example, we're actually going to be using a constructor. In this situation, first we have a parent object, which is a person prototype, and it has a DNA that contains a method of greet. Then we follow with our constructor, which is a person constructor, and it allows you to pass a new name every time you create a person with this constructor. The name gets assigned to an internal property of name. And the next step is actually use an object.assign, where we say every object that gets created with a person constructor will actually receive all the properties of the person prototype. In other words, we assign the prototype of the person constructor to the person prototype object that we had created in the first step. You see an example here. We are creating a new baby object called Ruben. We initialize it with a constructor by calling new person and giving it a name. And since we have assigned the person prototype to the original object that we had created in the first step, Ruben will also inherit a method of greet via its DNA. So it says here that it's common to see a pattern in which the methods are defined on the prototype, but the data properties, like name in this situation, are defined in a constructor. So the properties like name that are defined directly in the object are called own properties. And you can check whether an object has its own properties or just directly inherits from another prototype by calling object has own method. Over here, we are creating a baby object called Irma, and we're giving this object a name. When we ask whether object has own name for Irma, it returns true because yes, name is its own property for Irma. However, if we're asking if object Irma has its own method of greet, we're going to get false because false is actually inherited from the parent prototype. Let's go back to our interview assignment and open a GS Fiddle page. Yes, I'm old school like that. First and foremost, let's write out an assignment. So first, I'm going to go with an easy example and add a custom method to an array that returns the first item in the array. Let's start here. So what we're going to do is we actually going to add that method to the array.prototype. This way, every new array that gets created in your application will inherit this method directly from the prototype instead of having to inherit a custom prototype from a custom object. What we're going to do is we're going to assign a function directly to this method. We're simply assigning a function to this method. And the first step is we want to make sure that the array is actually not empty, because an array can absolutely be empty and have no children whatsoever. Let's check if it's not empty. How do we get access to the array inside of the prototype method? Well, we're going to do this with a this. A quick refresher on this, going back to Mozilla documentation, it says this keyword refers to the context where a piece of code, such as a function's body, is supposed to run. More typically, it's used in object methods, where this refers to the object that the method is attached to, thus allowing the same method to be reused on different objects. So the object in this situation is an array. We're adding a method to the array's prototype, and this is going to return an exact array that we're trying to call this method on. So what do we do to find if an array has children? Obviously, we're going to check its length. See if length. One thing I like to do is I actually like to reverse my if statements and check for the negative statement first and say, if the length of my array is actually indeed 0, I'm going to return null. However, if it's not 0, that means the length is 1 or greater, I'm going to return an item from the array with an index of 0, which is always going to be the first child within the array. Another way to go about it would be, instead of returning null, to actually return -1. And this could be a good approach if we were to follow an array get index method. When you are trying to pass an item that's supposed to be an array and try to get its index, if the item is indeed not present in the array, you're going to get a -1. However, I'm not a fan of this approach because we're actually not asking for the index, we're asking for a child. And I would rather return null because I either get a child or I don't get a child, versus in get index, you get a number all the time. And this number can be anywhere from 0 to the length of the array -1. Or if you don't get that item, that's still a number, and instead of being a 0 and any positive number, it's actually -1. So in this regard, I would like to keep it to a null versus an item if the item is present. Now let's try to run this method and give an example of an array. I'm going to have an array of numbers here and run the first child method. So let's assign the result of this method to a variable and go into log this variable when I run my code. So you can see that I have gotten 6 as my first child after calling the first child method. Looks like it's working. Now the next assignment is actually going to be the FlatMap method to the array. So the FlatMap method does exist on the array object in JavaScript. Again, you can find it in the Mozilla documentation, but let's not look at it for a very long time before we actually try to execute it on our own. Now, similar approach. We simply go into create a new method. We're not going to override the FlatMap. Instead, we're going to add a method that is called myFlatMap and assign it to a function. Assign it to a function and open parentheses. Similar to our first method, I'm going to reverse my if statement and check if the array actually has any children first. I'm going to say if this length equals 0, I'm going to return an empty array. So over here, the FlatMap is always supposed to return an array, not just any array, but a single dimensional array. If there is no children in a FlatMap, there is nothing to flatten within the array, so we naturally are going to simply return an empty array instead. One thing to keep in mind is that in the FlatMap method, you actually can pass a callback. This means that as you are iterating through your array and essentially taking steps to flatten that array, you can also apply a callback to each item within the array as you go through your loop. So we have to make sure that we allow users of this method to be able to pass their own callback as well. We're going to add callback over here. Now, next steps, how do we go about it? Obviously, we need to iterate over the array. As we go in through this array, we are going to continuously add every single result of our iteration into a single dimensional array and try to return the single dimensional array back to the user. The best way to go about it would be to use reduce. Let's go back and look up reduce real quick. So the array reduce method is something that I gotta be honest, I don't use enough. It executes a user supplied reducer callback on each element of the array. It's passing in return the value of the calculation, and the final result of running the reducer across all elements of the array is a single value. In our situation for the FlatMap scenario, the single value is going to be a single dimensional array. But a good example would be a mathematical example over here. So we have an array of 1, 2, 3, 4, and we are trying to essentially calculate a sum of all those elements within the array. So sum with initial means that you also have to pass an initial value. In this example, the initial value is 0. So with reduce, that you see that we have an accumulator and the current value. Now for sum, we are simply adding current value to the accumulator and passing an initial value at the very end of this equation. But remember that the initial value is actually optional. So now we need to add the result of every iteration within the reduce method to our accumulator. And remember, our accumulator at the end is going to be an array. So how do we add set of values that can be a single value or multiple values if we are working with a multidimensional array to a single dimensional array? We are going to concatenate it. But before we actually concatenate the value, we need to apply the callback. Now over here, don't forget that we need an initial value. And the initial value in this situation is going to be an empty array. So we simply are going to return the result of this reduce function. Let's see. Let's create another array that has multiple dimensions. Now over here, we're going to assign result and run our custom method on this array. We need to remember to pass the callback. So in this situation, I'm simply going to return the original value. And as a result, we get our original array flattened. So now if we actually pass a different callback, does something else to transform this array, it can look something like this. We want to return the value as well as the value multiplied by 2. Let's run this. As you can see over here, we're not really going down multiple layers. So if we are passing the callback that is supposed to return an array, we are not going to flatten this. However, if we try to apply the same method to the original array that didn't have multiple layers, we're going to get exactly the method that we're trying to execute applied to every single element of the array. For us to be able to flatten a multidimensional array, even if the callback is actually returning an array method, we need to follow a recursive method and make sure that the value returned from the callback is also being flattened in its turn.